Is this our notes?
All right. Just for your reference, I am videotaping this lesson today. So be careful what you say out loud. Everyone. All right. Where's my clicker? Okay, so we're going to spend some time on this slide, and I'm going to repeat quite often what this slide is saying, and here's why. Being able to write ionic formulas and ionic names using your transition metals was one of the skills last year. It took my kids a long time to kind of master, okay? And when I say a long time, I mean we got into units 4, 5, 6, and even 7 before some of them just kind of buckled down and came in and say, I don't know what I'm doing, you need to reteach this to me. All right, some of that I got, like, that was an actual thing that they said, okay? So what I'm trying to say is this was one of the most missed things on our test last year, was this skill right that we're doing today. So if you find yourself dozing off, I have to have the lights off because of the glare for the video. If you find yourself dozing off, you will miss something very important, okay? If you need to stand up, go stand up, okay? I don't care. But today's very important because this was one of the harder skills, more difficult skills that my kids struggled with last year, okay? So you will also, if you have a periodic table, like your colored ones that you use at home or that you colored on that are, I keep telling you to keep at the front of your notes, you're going to want to get that out today as well. You don't need any colors with it. But here we go. So it says that many transition metals have more than one possible oxidation state. You can cross out that word state and just, it's the same thing as number. All right. If we review what an oxidation number is, remember if you're getting out your periodic tables out and you didn't number these the other day, you should have positive and negative signs over all of your A families, all of your A groups, right? So positive 1, positive 2, positive 3 over boron. You guys remember talking about this? And then negative 3, negative 2, negative 1. Those are the oxidation numbers of each one of those families. Okay? So when I say that magnesium it reacts with oxygen, and I want you to write down the chemical formula for what happens when magnesium and oxygen get together, what's our first step to figuring out what that formula is? I'm not the Louis Dash, I just put the formula. What's the formula at the end? The shortcut. I switch, what am I switching? The oxidation numbers. Where do I find the oxidation numbers? You look at your periodic table, right? Magnesium will have an oxidation of what? Positive 2, because it will want to lose 2 electrons. Yes? What is oxygen's oxidation number? Negative 2, because it wants to do what? Gain 2 electrons. Right? This is review from last class. What do I do with those oxidation numbers? I switch them, and now I have Mg2O2, and what do I do with those 2's? I simplify. I divide by the greatest common factor to get the most reduced answer. And there you go, MgO, magnesium oxide. Magnesium oxide. Any questions with that? So, what today is that we're dealing with certain types of elements over here. And this is where you're going to want to maybe label your periodic tables, okay? So from now on, I'm going to kind of be grouping all of your cations into 3 different groups. Your first group, I'm going to say A block. Your A block is your first 2 families. Why do I call them A blocks? Because they're metals, but they fall in an A group, right? 1A and 2A, which means we know their number of valence electrons, correct? So that's A block. Then we have your B block. These are all your transition metals from scandium down all the way across to underneath your underneath your staircase, right? Those are your transition metals. I'm calling them B block metals because they all have their group number as a B next to it. Follow me? B block. That's not a whole lot of new stuff. The new thing to you is your exception block. Your exception block are these three up here, plus you need to add these. I'm not sure why they're not up here. But you also have silver, aluminum, you have germanium, or gallium, gallium, and you have indium. These are in the same family, right below boron. Okay? And if you look over here at my periodic table, and you're probably going to want to indicate this on your periodic table, if you look over here, these are all the elements that are found in this rainbow tape over here. Y'all see it? Yes? Okay? Now, we've already talked about aluminum last class, right? That aluminum has the same properties as boron. Correct? So all of these right here will have a charge of +3. Silver +1, zinc +2, cadmium +2. Now, you will have to memorize these. However, they go in order. They go in order. In America, we read from left to right. Yes? So if you look over here, silver is +1, +2, +3. Okay? Now, you have to be careful. Does copper fall within this tape? So does it have a +1 charge? It can, we just don't know. Right? Does mercury fall within this tape? So do we know its oxidation number right now? We don't. We only know these 6 plus your A block. Yes? And then all of your nonmetals we know. Well, we think we know. Okay? Why is that so important? Why have I spent the first 10 minutes talking about different sections of your cations? Because of this last part. This is really one of the biggest new things for today. That other than transition metals, as well as lead and tin, don't worry, they require a Roman numeral. Okay? So, anything that's in your A block or your exception block, so these all right here are your exception block metals. If it does not fall in your exception block, if it does not fall in your A block, you have to have a Roman numeral in the name. You have to have a Roman numeral in the name. If you don't, it will be wrong. Okay? That's just the way it's written. The Roman numerals that you will need to memorize, if you don't know much about Roman numerals, you need to, right? So the I is 1, double I 2, triple I 3, IV 4. If you don't know that, you need to write it down, and you will be required to memorize the first 4 Roman numerals, because this is what you'll be writing in these metals names, in these B block metal names. This will not be accepted. So if you write something like lead 4 chloride, that will be wrong. It has to be lead Roman numeral 4. You see what I'm saying? It's just the first 4. Most of you probably already got it, but just I want to let you know what will not be accepted. Okay? Yes. Yes. Yep. This is the same with lead and bismuth. So it's these 6. I don't know if you have another highlighter, if you have something that you can color these 6, like and label your exception block. I don't know what you need to do. Okay, that will stay up there, but obviously it's not that easy to see. Question? No. No. Good. Yeah, if there's an emergency. All right. So here is that periodic table. So if you're not sure exactly what I was talking about or what I was pointing to, this is a slide. You can access this slide on Canvas. But once again, A block here, exception block here. Then all of these, and that kind of answers your question. Look, all of these over here, these are all B block. Everybody got it? Right? Once I started asking my kids questions about these specifically over here, they thought that they fell within these known valence electrons, and they don't. We got to figure them out. All right? The only ones that we know for sure are those 6 and A block. Okay? And once again, why am I hitting on this so hard? Because if you go to name these here, they have to have a Roman numeral with their name. If you don't, it's a very quick grade for me. All right? Especially if you just leave the Roman numeral out completely, let alone give me the wrong Roman numeral. That's a little bit more acceptable of giving me the wrong one than just leaving it out completely, which means you didn't study, you didn't even do the homework or anything. Okay? You didn't pay attention. Only B block needs Roman numeral, okay? And here's why. The Roman numeral tells us how many valence electrons it has. It tells us its oxidation number. Not valence electron. It tells us its oxidation number, all right? So this copper 1, so I will give you, like this is the one way I'll give it to you. If I say copper 1, well, why is that so important? I just gave you its oxidation number. And that oxidation number is that Roman numeral. Oxidation number is that Roman numeral. Why do we need to know oxidation numbers? So we can cross them up, right? If I look over here, would I have known what this final chemical formula is going to be if I didn't have these up here? No, I can't do that, right? So over here, if we don't know what copper is, how are we supposed to get the final formula, right? Well, because I put that 1, now I do. Now I know what oxidation number to put above, which is why you see this copper, and that's a little funny, it's just hard to get it right above. It's copper 1, all right? If I had iron 2, and I went to put it into a formula, iron with a +2 above it, how do I know where that +2 came from? The Roman numeral. Not difficult, right, if you're kind of just watching. It's just something you have to practice, okay? 10-4. 10, that 4 is its oxidation number, which means if I use 10-4, I'm using this 4 to cross down into whatever else I'm reacting with it, okay? And once again, it's helpful if you've labeled your oxidation numbers on your periodic table, especially to use at home, okay? Now, I'm going to go through a bunch of rules. Yes?
So our transition metal is always going to be a positive ion?
Yes, because they're cations. Does that make sense? Yeah, and I'm glad, we do need to make that connection, okay? These are always going to form something positive because they are all cations, right? I'm going to give you a bunch of rules on how to do this, and it might make sense, but it's going to make a lot more sense once we do the examples for it, okay? That's kind of how some of the things go this year. Like I give you all the rules, it doesn't make sense until we actually have to do it, all right? So, from now on, especially once we get to Unit 4, but specifically in this unit, I give you a chemical formula. And you have to name it or write its formula. Your first question has got to be, is it a metal bonded to a metal, or a metal bonded to a non-metal, or a non-metal bonded to a non-metal, all right? Because there's 3 different types of bonding that we've talked about, right? That's where it says, find the metal in the periodic table. So if I have a metal bonded to a non-metal, I know that that is ionic. That was a part of your quizzes today, right? Yes, remember that question? That's a very important skill, okay? So, but for this unit, it's almost always going to be metal and non-metal, all right? Your next question is this step 0. You have to figure out, where does this metal belong to? Which is why we just kind of labeled your periodic table, right? Is it A block? Is it B block? Or is it the exception block? Right? Because if you decide because you need to decide if it needs a Roman numeral. So let's kind of do a quick practice. If your first metal is sodium, Find sodium. When you write sodium's name, do you need to have a Roman numeral with it?
No.
You do not. What if you have titanium?
Yes.
Does it require a Roman numeral? Yes, it does. What if you have cobalt? CO.
Yes.
Yes. What if you have lead? PB. Does it? Yes, it falls outside of the exception block. What if you have silver?
No.
Because that's in the exception block. You see what I'm saying? Like this is sometimes this gets to be a pretty easy grade for me because I'm not even looking at any of the spelling. I'm looking at, do you have a Roman numeral or did you put a Roman numeral when you weren't supposed to? That's a pretty quick grade, okay? So you need to figure out if you need a Roman numeral or not before you get the process started. And really from there, it's kind of straightforward of what we've done before. Okay, so find the metal on the periodic table, decide if you will need a Roman numeral or not. All right, today a lot of times you will. Name the metal first and then use the Roman numeral to indicate the oxidation number. All right, so what do I mean by that? Let's say I'm working with copper 1. I write down copper, and then I put that 1 in parentheses. If you forget your parentheses, I am going to count it wrong. All right? Okay? Now, the hard part, and we will get to this hard part later, is finding what this number is supposed to be, because that can be pretty involved. That's the difficult part of this, is what screwed up a lot of people last year. Okay? Then let's say we're doing chlorine, copper and chlorine. Then it's just the same rules as before. Chlorine turns into chloride. We just change it into IDE. All right. So to find the oxidation number, we're going to do something called uncrisscross. That means we're going to bring the charges back up because those charges tell us the oxidation number. This is where it gets a little bit involved. And we'll talk about what happens if it is or it is not correct. These aren't going to make any sense to you until we do it. Okay? And we're going to do it here in a second. All right? So, writing formulas, right? Copper 2 fluoride. So I want to write this down. We're going to do this one first, the most practical, this first, right? I give you the name. You need to write the formula. Yes? The easy part is this one, going from the name into the formula. Because what does that 2 tell me about copper? Well, copper's a transition metal, but what does that 2 tell me about copper? It's an oxidation number. So when I go to write copper and fluorine, what is copper's oxidation number? What number goes above copper? Plus 2. What number goes above fluorine? Well, we didn't look at the periodic table for this one. It is what? -1. What do I do with those numbers? Cross them, and now I have CuF2. Yes? All right. So, let me do the first one with you here, and then you have a chance to work with your partner on the other couple. We'll come back to this here in a second, okay? So, tin, 2 chloride. So I know I have SN is 10, and chloride comes from Cl. Well, what is tin's oxidation number? It says it right there. +2. What is chlorine's oxidation number? -1. Cross those up, and you get SnCl2. I can draw my arrows so you know. Okay? Go ahead and try the other 2 on there, and once again, by all means, work with your partner. Make sure you are reducing if you have the option or if you have the chance to reduce. The most reduced answer is will be graded. Let's pull.
Yes, I got I almost cried during the
Okay. So this bottom part, this is the easier of the 2, to go from the name into the formula. The harder of the 2 is down here where we got to go from the formula into the name, because we've got to figure out where that Roman numeral is going to come from. And I'm telling you right now, you all need to look up here. You need to look up here, because somebody is going to do this. And it's going to be unfortunate. If you say, okay, I know I need Roman numerals, and I know that Roman numeral comes from the uncrisscross, the charge that got put into the other element, right? So a lot of you are going to be tempted to go, okay, this is going to be lead 2, this is going to be copper 1, and this is going to be tin 4, right? If you think along those lines, you will get about 60% of your test right. That is not how we do it. That's not the pattern. Those aren't the rules, okay? You need to follow along exactly what I do, because there's one very important check that you need to make every single time to make sure you're going to be right every single time, okay? And it's not going to be a fun check, all right? Here we go. So what we need to do is uncrisscross, because I need to know what is that charge above lead, because if I want to get some momentum going, this is lead something, right? Lead's a B block metal, so I need a Roman numeral, correct? And the rule is I write out lead completely, and then I need a Roman numeral, so I did that. And then this chlorine turns into what? Chloride. What's that?
Oh, never mind.
So this is just normal what we learned the first day. The only difference is I got to figure out what that Roman numeral is. And this is the hard part for today, is what Roman numeral is going to go in there. And once again, if you think it's just going to be that number every single time, you'll be wrong 60%. Now, you're going to be right 40% of the time. Just by happenstance. You're going to get lucky, to be honest, okay? You're not going to be right most of the time. So, what we need to do is uncrisscross. Right now, I have this. Yes? What do I mean by uncrisscross? Well, where did this 2 come from? It came from the top right there. So right now, I'm thinking that lead has a positive 2 charge to it. I could be right, but I could be wrong. How do I know? Keep going. What number is implied right here that lead has?
1.
Where do I need to uncrisscross it to? Right? And so this has, I'm thinking that chlorine has a -1 charge. Let's backtrack to day 1, Noah. Why is this always going to be positive? It's your cation. Cation's always listed first. Why did I put a negative on this one? It's your anion. It will always be negative. Yes? This is where your check comes in. So right now, if I kind of clean this up, this is what I have. Would you all agree? Yes? This, I need to check my anion every single time. Because when I wrote this number 1 right here, did I check my periodic table, or did I just get it from this formula? I got it straight from this formula. That doesn't mean it's right. Okay? However, does chlorine, now that I have the -1 up there, does chlorine have a -1 charge? Yes, it does. That's a great thing for you. Because if that is correct, then that means that charge is correct. So this was one of those cases to where if you did say lead 2, you would have gotten it correct. All right? However, your reasoning behind why you got it correct would have been incorrect. If you need to do this check every time, what I mean by check, you need to check that your anion charge is what your periodic table tells you that it should be. Okay? Let's do the next one. All right? So this is the process I should see probably throughout this entire unit. Some of you are going to get pretty good at this and just be able to see it. Copper oxide. Everybody watch, especially if you were out. Copper oxide. First off, how many coppers does it look like I have right now?
1.
So that 1 gets uncrossed up to here. What about oxygens?
1.
It appears that copper is going to be a +1 charge. It just looks like that. So if I go over here and write copper 1, Oxide, why is that incorrect? Oxygen is not correct. That has to be a -2. It has to be a -2. Okay? So now I got to go back and do some work. What has happened here is that there's been some reducing. Right? Remember how I said reduce if there's a common factor? They've reduced here. I've got to unreduce to get the correct charge on copper. Okay? How do I do that? It takes a little bit of math, not hard math though. So, what I'm going to do is I'm going to rewrite this. Oxygen has to be -2. I know that for a fact. Right? So, when I cross that -2 down here to copper, I get Cu2. Would you all follow that? Yes. So now comes like a little game, puzzle, if you like this, like fill in the blank type of stuff. I have an unknown charge on copper. I know for a fact it's got to be 1 through 4, right? Because that's all the Roman numerals I told you to memorize. It can't be 5, it can't be 6. Okay? When I cross, here's kind of like the puzzle, the word problem. When I cross that charge down to copper, what charge does it have to be? So when I reduce those two numbers together, I end up with that. If you don't know, try 1, try 2, try 3, try 4. And at some point, one of those is going to have to answer that question, right? Some of you can see it already. That number is going to be a 2. Why is that a 2? Because 2 and 2 can reduce to what? 1 and 1, right? Which is what I need. Okay? And so that 2 tells me that what type of copper do I have? I have copper. I have copper 2. So this is copper 2 oxide. This is copper 2 oxide. This is the check that you have to do. You have to check your anion charge. If it does not match up with what you know to be true, you have to do some work. You know that some reducing has gone on. You have to unreduce to find the full charge on your transition metal. That way you can write down the right Roman numeral. Okay? If I go to 10 chloride. 10 chloride. Well, I know it's going to be 10 something chloride. Yes? Question?
So, chloride is naturally a -1, right?
Mm-hmm.
So it has to be -1.
It has to be.
And then, so that means, how do you get all the way up to 4?
So, this is what I would do if I were still learning to do this. And this is what I would expect most of you to be doing at the very least through today's homework and today's lesson. 10, and then I have Cl4, right? When I cross that back up here, I'm assuming right now that that's 4. Then this number right here is the implied what?
1.
The implied 1. That gets crossed back up into here as -1. Then I've got to check, does chlorine have a -1 charge?
Yes.
Yes, it does. If that checks off, we're good on both sides. That checks off. So it is 10,4 chloride. What's that? And once again, you would have, by chance, got it right if you did your original way of thinking. I would be very careful putting any more generalizations on these things. I would double check it every single time. Mm-hmm. That is 10,4 chloride.
Which is another problem. How should we get more?
4 goes above 10, not chlorine.
Okay, but in the last problem, you have to switch out the other
Mhm.
right? So you switch it to
Because this checked out. The other one was oxygen. This was oxygen, which has a -2 level, right? Chlorine got that 1 from, because it was just SN, right? SN, there's one S in here. So when I uncross it back up over here, chlorine does have a -1 charge. So we're good. If this checks out, if it's the right charge on it, that has the right charge on it. Nope. No, we do. That 4 goes back up above 10, so it's 10-4. So you have your homework. The top of that same homework page, page 4, or the bottom? Which one? Top. The top is what you should be working on right now with your person. Because they change. So I think that's kind of what's making some other. Guys, please listen up here. Look, listen. If we go back to the very first slide said that all of your B block metals will have different charges associated to them. I don't know if this was confusing some people. On one problem, you might find that lead has a +4 charge and you think you're right. On the next problem, lead might happen to have a +2 charge and you still think you're right. You're probably right on both of them. Does that make sense? They don't have a set number of valence electrons. If they did, we wouldn't be doing all this mess. I would tell you what it is and you'd have to memorize it, right? Like we do for the A block, an exception block. But we don't. They have multiple charges on them. We don't know what that charge is until it reacts. Or if I just straight out tell you. Okay? So don't get confused if 10 has 4 different charges on the test. It could.
So in order for it to cancel out, lead will have to have 2.
I feel like I wrote this down. Whatever. So then it'll be
So you tell me when you're ready.
Will help me whenever we're ready to put you have to change it because if we're not having a negative right here, then just
That's telling you that you
this
don't need it now.
and if it doesn't have anything,
Because the rest of the year.
it gets your brain.
This Mr. Stuckey? No, I have students, yes. I do. Yes, I will. Yep. Ellie. See you.
He's actually ugly.
I don't know. It was supposed to rain this morning. It never did.
I'm gonna take a good nap, but I can't.
Sounds fantastic.
So Mr. Stuckey, do you think I could get eagle's nest in here? Couple eagle's nests?
Yeah, you tell me when.
Okay. Do you think I could start with one for tomorrow?
Hmm?
Okay. So I'm thinking maybe if I start studying tomorrow or study the
Here,
weekend.
you fill it out.
Okay.
I'll sign.
So the date will be
14th.
Monday, tomorrow's date, right?
14th, yeah.
14th.
Look at this. This is gonna be fun. when do we get our progress reports? Cause I paid. Oh, what? No, my mom said that they'll help us.
Do you guys know what time Eagle's Nest is? 10:21, I think.
I think it's like 10:27.
10:27.
Or 10:28.
Oh, it's up on the board. Yeah, 10:27.
To Kate? I heard it. She said that. It's like, I was like, okay, this isn't my story. I thought we were best friends.
Mr. Steinke, what room number is this?
221.
221?
It's okay, I'm waiting for poetry. Poetry? Like literally just
Right, so all I need
I literally said it.
Alright.
Yeah.
Or after, you gotta figure out. Just do the same. Typically, unit 2, a lot of.
Reading this?
Out there, that we use all just basic chemistry stuff.
We're so smart. I'm so iced
Right? It would be like lead items.
Yeah, I just did not write it. I just was like, edit for my grade.
You're a junior, right?
Yes, I'm very much lazy. I did not feel like writing that out. He knows what I mean though, so.
Tell me when you're ready for it. If you wanna come in and just talk about it.
I was like,
Tell me when you're ready. I don't care if you say calculate. About 2 weeks to calculate.
All right. So most of you at least got a good jump on this. I want to draw your attention to not that. The bottom of page 5. The bottom of page 5. Nobody's probably gotten this far because there's some things I've got to teach next class for this. So listen to me. Listen to me and I'm going to let you work. You have to start thinking about how you're going to be tested on this. So far, I've sectioned off everything for you. Like in this section, do naming of just A block and nonmetals. In this section, do formula writings for A block and nonmetals. In this section, do transition metals and this, right? In this section, write the formula for, I don't do that on a test. Do you see what I'm saying? Like it's all over the place. At any certain time, I can give you any type of which way A block and nonmetal or transition metal. And you have to be able to pick all of this stuff out from it mixed together, which is why we give you a lot of mixed practice with this stuff, okay? So specifically at the bottom of page 5, there's a mixed practice. This is where you can do all of these naming right now to see if you can pick out when you need a Roman numeral and when you don't. Go. That should be your first question. Your step 0 is now, from now on, is if it's a metal, where does it fall? What type of metal is it? If your answer is A block or exception block, you don't need a Roman numeral. If it's not, then you do need a Roman numeral.
So say that